with these parts. So we know there's a neutron, there's a proton and electron. Neutrons are negative, are neutrally charged. It's not like a charge. They're in the nucleus with a proton, which are positively charged. And they have electrons orbiting them. So, you want to explain? Um, it's lightning a plasma. Um,
Um, yeah, I would say, yeah, lightning is considered plasma. And then,
Bose-Einstein
oh,
condensate.
we do get to that
That
in
is
the
also a
next
form of
few
matter.
slides. Yeah, that is also so like the ones we were talking about, like the three main ones are what liquid, gas, and solids. And then I think in the future slide, there's also like Bose-Einstein condensate, and like there's a few more types of matter, but the main ones are just plasma should also count on the slide. But yeah.
Is there anything you want to add on this slide?
Um, no.
Okay. So waves. Waves are also super important in physics. So what are waves? Waves are disturbances that transfer energy through a medium or space. A medium is a substance or material that can transmit energy such as waves or light. And there are two main types of waves, transverse waves and longitudinal waves. Do you guys know like the difference between them? Or like could you give an example of like a wave? Like like there are waves in the ocean. You guys know any other type of waves?
Like it could be anything from like
Sound
earthquake,
waves. Yeah, that's
sound,
right.
yeah.
Sound.
Okay.
Yeah,
Yeah, light
light is
waves.
technically a wave. Mhm. Yeah, these are all good answers. Heat. Yeah, I guess heat would kind of count. Okay, so to go into like the two, yeah, microwaves count. Yes, microwaves. Anything on the electromagnetic spectrum counts as a wave. So here, the two types of waves are transverse and longitudinal waves. Transverse waves are waves that move up and down while traveling horizontally. Energy, waves can carry energy. Yeah. A few examples of transverse waves are ripples in water, light waves, and seismic waves. So like the anatomy of a wave here, there's a crest here, there's an amplitude here. These terms might come into play in like when we go through like oscillations and stuff. So try to pay attention here. So like wavelength is between two crests. It can also be between two troughs, but doesn't it's like the same as you can tell. Amplitude is from the equilibrium to a crest. Uh, and like it's not on here, but a period would be like one cycle of a wave. Like I don't know how to explain it. It'd be like one up and down. That would be one period of a wave. Y'all understand anything you want to add?
No.
Do you want to go over
The
longitudinal waves?
longitudinals, yeah. Longitudinal waves are basically the ones that compress, and like you can kind of almost think of it as like a spring or a slinky, like the ones that like kind of compress and then go out again, right? As you can see in the picture, a lot of the components, there's also like a lot of the components are the same. There's like a wavelength there's amplitude, there's movement, and then yeah, I think this picture does a really good job of visualizing a longitudinal wave.
It's like a slinky. Like
Hmm.
you would like press on it and like that. It's not like as common. I don't think we use longitudinal waves as much in physics as we use as long as not like in mechanics. I'm pretty sure it's more focused on transverse waves. But yeah, these are
Yeah.
also a type of wave here. Okay, kinematics. So kinematics. Okay, so any of you guys know what kinematics are? What is the other wave called again? Longitudinal and transversal waves. Those are the two types of waves.
And then just to clear something up, I think like these first few slides that we're gonna go through are just like the surface level, and then we're gonna like review matter and atoms again. So like all your questions that were on the matter, we'll go deeper into that in like a few minutes probably. So yeah.
Yeah. So kinematics, if you guys aren't sure, is um, like the study of things in motion, or yeah, motion of objects. That's right. It's like anything in motion. Like this, like if anything is moving in physics, it's like a kinematic, like kinematic things. Kinetic energy. If you guys know what kinetic energy is, describes motion of objects. Yes, yes. All very good. So we might get into some math here, but like it's all like super simple. So position, you guys know what position is, right? Like it's a location of an object. Like it could be On like the X and Y axis, we would use like coordinate points to describe position, right? In physics, we use meters, seconds. What's the other unit? I don't know, but we use meters in physics and seconds. I don't remember what the other. There's a third letter for something. I'm not sure. Okay. So position, location of object is measured in meters. Yeah, kilogram. It's yeah, MKS, meters, kilograms, seconds.
Oh, okay,
Displacement
okay.
is change in position, which is like kind of self-explanatory. So if you're like 7 meters away and now you're 3 meters away, your displacement was 4 meters. You should also note that displacement is a scalar. There's no sign to it. Like it if you go forward and backwards and then back forward, you're at the same spot, right? So if you take 2 steps forward, take 2 steps backwards, you're in the same spot, but your displacement still increases because it does no direction to it. It's just the change in position.
Hmm.
So velocity is the speed in a direction. It's measured in meters per second. You guys like velocity is like speed. Like speed is technically a scalar. Velocity is direction. Um, Acceleration, change in velocity per second. This can like be kind of hard to visualize, but like when you're in a car, you have like a set speed, right? Say like you're going 60 miles an hour down the highway, but suddenly you change from 60 miles an hour to like 70 miles an hour, which you shouldn't do, by the way, that's speeding. You'll have an acceleration then. Like there's a change in velocity. So not only are you constantly changing position because velocity is changing position, you're also changing your velocity. And time is just the duration of motion, which is like self-explanatory. You guys all know what time is. It's measured in seconds. Yeah, that's it. You guys got gonna add anything?
No, I think we should clear up what a scalar, like the difference between a scalar and vectors,
Oh
though,
yeah.
just real quick. So, like a scalar is something that like only tells you how much there is. So, like, weighing like 50 kilograms, that's a scalar because that's only like that's like the size, right? Versus a vector is like sorry, scalar is like magnitude, right? So there's only one component, right? Weighing 50 kilograms or something like that. A vector uses magnitude and direction, right? So velocity, for example, is a vector because you're going 60 miles per hour. That's the magnitude, right? And then north, right? That's the direction. So having a vector is a little different from having a scalar, right? And a lot of kinematics is using vectors and scalars, and it's good to know the difference between the two. Do you want to add anything to the vector scalar, Lucas?
No, but VJ asked a good question in the chat. If you're in a circle and you're going the same speed, the velocity is still changing because velocity includes direction in it. And like if you're in a circle, like if you think about it, you're constantly changing direction. Like even though you'll have a constant speed, your velocity will be changing because velocity is a vector. It tells you how fast you're going and also like what direction you're going into. So that's like it's like a difference between speed and velocity. They're not the same thing. That was a good question. Okay. Kinematics. So types of motion, there's linear motion, which is like straight line movement. It's pretty simple. There's projectile motion, which is my favorite. I think it's super interesting. It's like how gravity affects motions. We don't usually take into account air resistance here. Rotational motion, which is object rotating on the axis. This is like more complicated. You should have a pretty good grasp on like linear motion and like projectile motion before you move on to rotational motion. Even though it's like parallel because there's new variables and like there's also new things that you're taking like inertial rotational inertia and stuff like that. It's different.
And then you can look at
Um,
the pictures. I think they do a pretty good example
oh
of
yeah.
displaying all three.
So like this would be rotational motion. Uh, you're like applying torque in the situation. Projectile motion, you're shooting a ball. And there's also linear motion, which is this little kid walking. Oh, if I'm going too fast, you guys can always like ask for explanations. Don't worry, because like we're super open to explaining stuff. Okay, so types of motion. Oh, this is
Oh, did I miss? Sorry, this is a question, right?
oh, okay, yeah. Yeah, this is the question we kind of walked through it. So a car starts from rest and accelerates at 3 meters a second squared for 5 seconds. How fast is it going after 5 seconds?
Do they want to do it first?
Oh,
Like take a minute to try
yeah. Do you
and
guys
then
want to
we'll
try
go
solving
over.
this? Because we can always go over. This is the first question, so we'll go over it.
We'll give it as a minute.
Yeah, we'll give you guys a minute to do this. Oh, wait. Also, if you guys like get the answer, make sure you guys can like keep it
Private.
until the time is up, so you don't spoil it for other people.
Yeah,
It's okay, Michelle and
either
Aaron. It's okay. We didn't tell you. No, no, no. It's okay. It's okay.
yeah. If you wanna give the answer, just privately chat one of
You
us
can
and we
message,
could, yeah.
yeah, any
And
of
then we could
us.
tell you guys if you're right. Yeah.
Okay, yeah, yeah. A lot of you guys have the answer now. So this is like a pretty easy question, right? But I'll go through like the process you would do. Like this is the same like methodology you would use to solve more complex questions. So first we would look at like information we're given, right? Which is like super nice in this question. They already tell us what we know. I like normally in questions they won't give you this, but this is here. So initial velocity, which we often use as v naught here, is equal to 0 meters per second. Acceleration we're given is equal to 3 meters per second squared, and time is equal to 5 seconds. And oh, my handwriting's pretty bad. Sorry. And we didn't go over the kinematic equations earlier, but you can also solve this like without you don't really need a kinematic equation here. But there are equations like for more complex questions. I think they're somewhere around here, the next couple of slides. I'm not, I might be mistaken. But yeah, okay. We start at 0 meters per second. Acceleration, which we know is change in velocity, right? Is at 3, and there's 5 seconds to go over it. Yeah.
I
So after
think
1 second, there will be a change of 3 meters per second. And after 2 seconds, it'll be 6, and so on, which will just end up to be 15 meters per second. Finally, I'm trying to find the kinematic equations because that gets sums it up. Gotham, do you know? I don't have it memorized anymore. Can you cover
which
what
one?
the kinematic equations? I probably have it.
You have what AT equals V. You have initial velocity times
Here,
time plus
I
one
wrote
half
it.
AT squared equals D. I think it's on a
Yeah, I have it here. So here v, so velocity is equal to initial velocity plus acceleration time times time, right? This like makes sense like conceptually, right? Because we know acceleration is changed over time. So if we take acceleration and we multiply it by time here plus the original starting velocity, it'll give us the final velocity here. And this is the same thing here. Um, we have a 0 initial starting velocity, and there's a 3 meters per second squared acceleration times 5 seconds. And this gives us a final velocity of 15 meters per second. Um,
Mhm.
it's also very important to like pay attention to your units here because in physics, units are super important. If you get the like number correct, but you get the unit wrong, they're only giving you like half credit for that question. Units are super important. Um,
And then oh, go ahead.
Oh yeah, I was gonna say velocity is always in meters per second. Acceleration is always in meters per second squared. So like your question is asking you for, I'll go over like unit analysis in this question too. But if your question is asking you for like position and your answer has like meters per second, you got the question wrong because the units always have to line up. So we can do this question with units too. Because units like
Yeah,
it's pretty much
that's
like you can
a
treat them as
joke.
variables sort of. So like initial velocity is at 0 meters per second here plus acceleration, which is in meters per second squared, right? Because it's meters per second over change in time, which is what, yeah, change in velocity times. And we know, you guys know what the unit of time is? It's just seconds. So it'd be 5, oh, I forgot the 3 here. 5 seconds here. And this like kind of cancels out. You guys know you can do that. If we're multiplying fractions like this, and like you have here, this times just a regular s here. So it'd be 0 meters per second because that's our initial one, plus 3 times 5 is 15 meters per second. You guys see that?
Hmm.
I have like pretty terrible handwriting. Gavin, do you want to, I can try it on paper next time. So yeah, 15 meters per second here. That's this question. And like, this is like kind of what you would use to solve like a lot of kinematic questions. You would take an equation, you would see what you're given, and you would apply them in here. This question's like super simple. You
And
wouldn't have to like write these units here, which is why I kind of ignored it here. But like in more complex questions, I would recommend using your units here because they're super helpful to know if you got the question correct or not.
okay, and then I just want to add this is like something called dimensional analysis, what like
Yeah.
Lucas did right here. And it sounds very complicated, but it's actually very simple. Where this question, you can just use the beginning of this question, right? how fast is it going after 5 seconds, right? So basically, it's asking for the velocity, right? So the answer needs to be in meters per second, right? And since we know that we're given an acceleration, which is meters per second squared, and the seconds, which is second, like Lucas did right there, you can just cancel that and you would get your final answer to be meters per second. And then you can kind of like just use the 3 and 5 and multiply them together. Like a lot of it, you could just almost like, I don't want to say guess, but use like educated guessing to like get your final answer and be pretty confident in it.
Yeah, so like if this is a multiple choice question and some of the answer choices had units that were not meters per second, those are like automatically wrong because we
Hmm.
know we're looking for velocity here. So our answer must have meters per second in it. So that's super helpful, like in avoiding a couple options. Okay, I'm gonna move on. Okay, so activities. We're on the activities now. Oh, okay. Well, yeah, these could be helpful here. Oh, we didn't go over like all these units here, but we can. It's a good landing
Wait,
point.
wait.
I don't think we
Oh
went
yeah,
over
yeah, yeah.
newtons. Okay, here.
Some of these activities are like aren't gonna be stuff we taught in the class, and we'll teach it like after the activity. So don't worry if you didn't like if you felt like you didn't get a thing because some of these activities are meant to be also like teaching. These are not like review activities as like a lot of classes do. These are like activities as in like things to help teach as well.
Yeah, there's like a wide range of
Aaron.
people and like knowledge here. So, oh, try not to type your answer in chat like before. You can private
Hmm.
message one of us, but it's okay. But Aaron is correct.
That's
The
okay.
first answer is newtons. Newtons measure first force.
You've probably heard of it before.
Wait, I have a harder question. Do any of you guys know what newtons are in like kilograms, meters, and seconds? Because Newton is a force, yeah, but there's also a like a translation of it.
We'll go through all these answers. I just realized how hard these actually are.
Yeah, these are pretty difficult.
Um,
Um,
Wait,
yeah, we'll give you like 30 more seconds.
that's crazy. I didn't know that I created these. uh, Sorry guys.
VJ asked a question. Newtons the force. Newtons are the unit of measure for a force. So like if you're applying a force, your force is measured in newtons, and newtons are kilogram meters per second squared, I think, right?
Yeah, yeah, that's right.
Yeah. Yeah, we can like show how. I think I actually don't remember the derivation, but there's a way to show that it's
You can
like,
just use the two. You can just do the equation now.
oh yeah, yeah.
Just use
But yeah,
mass and
so
acceleration.
if you are
Uh,
asking like solve for a force, you can use dimensional analysis. Like because newtons doesn't sound like anything, but kilograms, meters per second squared. If they give you like values in those units, you can solve for newtons and you can check if you're right. Dimensional analysis. I'm getting a lot of messages, so yeah, good participation, guys. You guys are doing good. So do you want to go over the answers now?
um,
We
do
can
you
move
guys,
on.
okay, so you guys can go back or just type in chat if you guys need more time or you guys want to go over answers now. I know one person's still solving so
You guys ready? God, meetings are ready.
Yeah, I think we go through.
All right, do you want to go through these questions?
Sure, why not? So the for the first one, I know you guys haven't yeah, you guys haven't done any of these questions. But so I think force is pretty explanatory, right? Force is basically how much you're applying on a different object, right? And for that we use Newton. And Newton, you guys might want to get a notebook and a paper or pencil out because I don't think we should go through the exact derivation, but basically force or Newton is equal to mass times acceleration, right? And that's through Newton's second law, right? Force is equal to F equals ma. Force is equal to mass times acceleration. I think we can go through the derivation another day, but if you take the mass, do you guys know what mass is measured in? Kilograms, right? So we can use dimensional analysis here to figure out the units of Newton, right? Mass is equal to kilograms, right? And acceleration, you guys know what acceleration is, right? We just did this meters per second squared, right? So if acceleration equals, can you repeat what we need to type? Oh, what we need to know. So basically the probably the only thing you need to know is force is equal to mass times acceleration right now. That's like the equation for force, right? Um Jeff then I'll answer that. Okay, so we know acceleration is equal to meters per second squared, and since we have mass is equal to kilograms and acceleration is equal to, can I annotate on your screen share,
Um,
Lucas?
wait, I think I can make it so you can.
Okay.
Here, you can
But
try it.
since we know, oh, there we go. Since we know mass, ooh, I'm not very good at writing on equals kg and a equals m over s squared, we have kilogram meters per second squared, right? If you multiply these units, you get Newton is equal to kilogram meters per second squared. Again, like we said, we'll go through what exactly force is and like how to get that equation later. But on the question two, what is the formula for the total work done, right? So if you think about work, you're basically um, work is basically the amount of force you apply in a certain distance, right? Basically, like imagine you're lifting or you're pushing a box over 3 meters, right? You're basically, give me a second, sorry. Lucas, can you take it from here?
Oh, yeah, of course. Okay, so work is just force times distance. So yeah, two is number C here. So like when you think about doing stuff, like when you do work or like when you use exert energy like in real life, you're pushing or like pulling stuff. And that's applying a force over a distance. This is how we measure work. So like say you wanted to push like a 20-pound weight 5 meters, that would take work, which is like work is like I don't know, like the use of energy sort of. It's force times
It's just
distance.
energy, yeah. It's like how much energy you're expending, right?
Hmm.
And then which relates to actually we'll just jump to question four then, which is the correct units for that energy is called joules, right? And basically joules is like exactly like what you think. It's like work, which is basically the force times distance, right? And then when you take the work over a certain period of time, then it goes into watts, right? I'm pretty sure it goes
Watts
into
is measure of
watts,
power.
which is
Watts is the unit
power,
of
right?
power.
So that's another one. I think we go through all this later. This is supposed to be like a overview of basically what
Yeah.
we'll do, but going back to question three then, momentum is equal to mass times velocity, right? Because if you think like a lot of this, you could almost think about it in your head. Like if you're taking in a mass and if you give it like 3 meters per second of velocity, the momentum is basically let's define momentum first, right? Momentum's like the almost the leftover energy something goes, right? So if you push like your friend, right, he's gonna move a certain distance. That's called momentum, right? It's the energy you give to your friend, and basically how much he's gonna move is basically his weight times the velocity you push him at, right? And that's like a basic overview. But yeah, this was a pretty complicated one, actually.
You guys did good though. I got all the correct answers. That's pretty good.
Hmm.
Okay, so these are more like open-ended questions. We kind of went over this, so if you
Hmm.
want, we can just go over this again, or if you guys want to try to like recall what you remember. Honestly, this kind of stuff is kind of like redundant. We could kind of just we don't have to make them answer it.
Yeah. Just think about the answers in your head. Do you want to go over the last one?
Yeah, okay,
The
I'll go over the last one though.
I like the last question. Or do you guys want to think about the last question for a second? You don't have to answer the first three, like the classical physics, modern physics, projectile motion. You can just do the problem at the end.
Wrote the one of the kinematic equations on here, which is like not needed for this question, not like at all, but like for more complicated questions, you should probably get familiar with this equation.
And then I had a quick question. Do you guys think it'd be useful if every class we went through like a review of what we did last class, or do you guys feel like that'd be too redundant? Like, let's say like next class, what we do is like we do like a 10-minute review of all like we actually put the equations up and then we do like a review of that, or yeah, okay. All right, Lucas, we got to keep that in mind.
Okay. Jane, write that down.
Oh, we're getting a lot of, yeah, Jethan, you got that. Write that down. But yeah, because next time we'll actually have the equations up, so it'll be a lot easier for you guys to see. And then we could maybe even go through two or three more questions that are a bit harder for you guys. You want to go through the answer, Lucas?
Okay, yeah. So a ball rolls with a constant velocity of 4 meters per second for 6 seconds. What is the final distance? So something I'd like to know is whenever they say constant velocity, that just means there's zero acceleration. Like acceleration is zero. Because we know acceleration is the change in velocity. So if there's a constant velocity, there's no change in velocity, so acceleration is zero. So in any equation, you can just set a to zero. So this is one of the kinetic equations. So then this term here, 1/2 at squared, is just all equal to zero because acceleration is zero and anything multiplied by zero is zero. So we can just ignore this term here. So we're left with x is equal to x naught. X naught, like if there's a zero, like at the bottom of anything, it just means initial, like the starting version of that, the starting value of that variable. So its final position is equal to initial position plus initial velocity times time, because this term is disregarded because it says constant velocity here. So we know also x minus x naught here is just displacement, or like I don't know. This question is asking for final distance, but we can assume that the ball starts at x is equal to zero here. We can assume that. But so this would also just be equal to zero here. So it's just really just x is equal to v naught times t. We also know that velocity isn't changing, so that's like not here is kind of unnecessary. So it's really just x is equal to v times t. So we know v is 4 meters per second, and t is 6 seconds. And note that is also asking us for a distance, which is measured in meters, and also our seconds cancel out here. So it turns out to be 24 meters, which was a lot of you guys gave me that answer. So good job, guys. Yay, good job, guys. That was good.
That's good.
Okay, moving on. Oh, this is fun. This is like trivia kind of. I'll give you make sure you guys message like Jane or one of us the answers. Don't type them in chat. Like just private message one of us.
Mhm.
So we'll give you like a couple minutes to do this.
Yeah. Okay.
This one is tricky actually. I'm not getting out. Not quite. This is like tricky stuff though, so don't feel too bad. I've gotten a couple answers though. Do you want to go over the answers now?
Um, you got a couple? Okay.
Yeah.
'Cause I didn't get many. I think they're all just typing to you.
Wait. Jane, do you have a lot of answers? So you think you're ready?
This is a bit tricky, yeah.
Okay, so I'm gonna go over the answers now.
Are we
So
good?
animals can see light that humans cannot. A lot of you guys got this one. This is true. This is correct. Humans don't see like the entire EM spectrum. We only see what we call visible light. And some humans can't even see all the visible light. Like if you're colorblind, that's like a skill issue.
Yeah.
So second question, nothing moves faster than light. Yeah, humans can't see infrared, but I think snakes can see infrared, right?
I don't know actually.
Maybe perchance. I don't know. Some animals can see stuff we can't see.
I know reindeer can like change like their like perception of light during season so they can see more predators. But yeah.
Hmm. Um, so nothing moves faster than light. This is true. So I know some of you guys said false for this, but this is true. Nothing moves faster than the speed of light in
Mhm.
our universe.
Yeah.
Um,
That was kind of like a like the way it was
yeah,
phrased
it's kind
made
of
it
a weak
seem
question.
like, but yeah, I think that's a really good thing to know that like nothing that can move faster than light because if it did, then a lot of things in this world would be disproved. But yeah.
Yeah. Light can move in a vacuum. A couple of you guys said false for this one, but uh, yeah, space is a
You can take
vacuum.
space. Yeah, you can take
Yeah,
space as a vacuum. Like space is a vacuum, and like if you think about the sun, clearly the sun can come to Earth, so like light can move. through a vacuum.
Hmm.
How about black holes? Could you expand? Like,
Um,
what do you mean on how about black holes? In the meantime, yeah, no, okay. The next one's false. Um, I don't think the moon's surface. Oh, that's because gravity. I'm pretty sure gravity has the same speed as light. It does not. It cannot move faster than light. Gravity. So there's like a certain point where in the origin or the black holes I forgot what it's called. I'm pretty sure Jeff knows, but where like light can't escape, but that's because like the gravity there is like so strong. It's very complicated, but gravity
light
does
can't,
move at the
yeah.
same speed as light. So if you think about it, like if the sun disappeared, you know how like light would light would only we would stop seeing light after 8 minutes because that's how long it takes to travel. Same with gravity. We would only go out of orbit after 8 minutes as well.
Yeah, that's interesting. Um,
Hmm.
but that doesn't mean light can't travel in a vacuum. Black holes are like different. Like vacuum is space, light can still travel through. Like our sun, sunlight comes through space because the sun is traveling through because the waves are coming traveling through a vacuum to get here. So a rainbow is caused by the reflection of light off the moon's surface. This is incorrect. A lot of you guys got this one right. A rainbow is not caused by the light off the moon's surface. It's caused by the dispersion of light through like raindrops, right? I think. Yeah,
Yeah.
pretty much like rain. I think it's dispersion.
Mm.
Yeah, it is dispersion. Okay, so like pretty much the little like water droplets or like mist, they split the light into they like since the white light is like all the lights together, right? And like they're all like slightly different wavelengths. So like when they go through the drop, they're all like impacted, like they're all reflected at like a slightly different angle, so it splits them. So like you
We
all
go
see
through
the
this unit as well.
oh yeah, like
And
yeah, it turns into a spectrum. So yeah,
mhm.
and a magnifying glass can make objects appear smaller. Is this true?
No, I thought it's false. I mean, wait.
Yeah, I
Okay,
think it's false
this
too.
is a tricky question,
I
but
mean,
it's
I guess it's like the lens it's asking about, but we're just
yeah,
gonna
it
call it
depends on like the
false.
lens.
Yeah,
But like most
magnifying.
magnifying glasses are supposed to like magnify an object, but if your lens is like a bit, is it a convex or a concave?
I think magnifying glass is convex.
So if it's the opposite, then I think it just makes stuff smaller. But
Wait, no,
yeah,
no, I'm pretty sure. I think this question might be true because when you hold like a convex lens, if you pull it away from like a certain distance, it like inverses it and it becomes smaller. So I think this is a true question.
really?
Yeah, it's been a while since I did optics. I think this is true though. Anyway, there's like a
I don't
point.
like
I
that
remember
much.
there's like a point where like past this point, it's a virtual image and it's flipped upside down. Anyway, this is unrelated to this question. This is I don't think we're going to optics that much. But yeah, that was a very hard question. Okay, activity four. Master the concepts. This shouldn't be too tricky. I think you guys got this.
Wait, like a lot of these activities were actually like really hard. So don't feel bad, guys.
Yeah, yeah, yeah. I'll give you guys like a minute to do this. I don't think this one's too tricky. If you need to slow down, you can always tell us too.
Are you getting all the answers, Lucas?
I got one answer so far.
You have gone?
Yeah, I got one answer so far. Jane, do you think they're ready? Oh, I'm getting a lot of answers now. Okay, yeah. Okay, yeah, Jane said they're ready. Okay. So you guys are pretty good on this one. Very nice. Um,
Yeah.
Position is the location of an object, number four here. Position is number four. I can annotate this here. Location of object, we went over this. Position is like where an object is in space. Displacement is the change in position. This is correct. Displacement is different from distance, by the way. So take that into account. Um,
Hmm.
Velocity is speed in a direction. Uh,
Distance is a scalar, right?
yeah, yeah, yeah.
Distance is a scalar, displacement's a vector.
Um, Acceleration is change in velocity per second, and time is the duration of motion. This is all good stuff here. This is pretty important to know. So if you have any questions, make sure you ask. I'm gonna move
Yeah.
on now. Is it okay?
I think this is the activity where it should be the most solid, concrete for you guys because if you guys get this, then a lot of it becomes a lot easier. So if you guys have any questions, feel free to ask.
Yeah, you can always ask us or Jane. Thanks. Okay. Um, what other parts?
Mm.
Oh, we already did this.
Yeah, you guys don't. Do you guys want to do this? No. All right.
Um, these are some games here that can help.
Can you?
Should we go over this? I can click these.
Oh, you can click these. I
Should we
think we
come
can
back to
go
this?
through.
Okay.
Do you guys want to go through it in chat, or just type in chat if you guys want to go through it? If not, then just say no. We either way, we're fine. They're pretty fun games. So
They're all physics related, so oh,
I
sorry.
also typed it in chat. So
You guys can click them yourself if you want.
mhm. Let's go through one. Let's go through one.
As a
You
group,
get to
which one should we
choose,
do?
Lucas. You get to choose.
Okay, let's do projectile motion. I like projectile motion. Okay, so intro. Oh, we did this in class before. Okay, so
Yeah,
this
you.
is a cannon, obviously, right? This is a target here, and we can fire the cannon, and it'll show us the arc of the projectile, which is pretty cool, right? Lots of cool stuff here. Hey, bullseye. So let's see. Okay. Okay, so in projectile motion, this is like more complicated than we know. But there is no horizontal acceleration. There is a vertical acceleration, which is the effect of gravity on the projectile. So if you can kind of imagine it, it's traveling in like an arc, right? You can see this arc here on the screen here. There's an arc, and at each point of this arc, there's a horizontal and a vertical component of uh velocity and acceleration. So the horizontal velocity, like the part that's pushing it side to side, like the velocity that's going side to side, is constant this entire time. But there is a vertical change in velocity. There's a vertical acceleration because there's gravity that's pulling down on the ball. So I don't know if I explained it well. Why is there a person? I'm not exactly sure why there's a person either.
That's a good question.
Um, okay. So well, okay, so pretty much what impacts. Oh, by the way, this is if you want something to go as far as possible, it's always at 45 degrees. We can like prove it later. But like every single other angle will make it less. It won't go as far. That's what let me clear it so it's clear to see. 45 degrees here. A 45-degree angle, like when the gun is flat, is the farthest the ball will ever go if there's no air resistance. You see, I can go up and blow it, and it'll all be less than the 45-degree angle. What else is there to go over in projectile motion? Um, if you want to calculate the distance, like the ball travels, you only need the the time it's in the air and the horizontal speed because there's no horizontal change to acceleration. If you want to know how high it goes in the air, you need to know. What do you need to know? You need to know.
Oh, sorry, I wasn't listening. What were you?
I was just trying to give things like to know about projectile motion. Let me think.
For the vertical or horizontal?
Like if you want to know how high the ball goes, what do you need to know? Like what values?
Um, you just use 1/2 AT squared
Yeah, you
equals
need initial. We
Y.
know gravity is 9.8 meters per second squared.
Yeah, so
That's
you
something
use
to write down, by the way.
G, and then you
You would
use
need to
sine
know
theta,
initial.
right? V sub zero sine theta T
Yeah,
plus 1/2
you
GT
need if they give
minus.
you yeah if they give you like the overall initial. Actually, this is something we can go over. Do you guys know like trig yet? Like sine and cosine? Do you guys know what? Yeah,
Oh,
this is more in depth, you know. But wait, does anyone here know sine and cosine? If not, we can explain it. Kind of. It's pretty complicated though, but it's very important in projectile motion a
yeah, I think
bit.
this is part of kinematics. So I think we should. Do you want to go? Do you guys want to go over projectile motion?
But I can go over like a little bit here. Okay, yeah, a
Yeah,
bit. Okay,
why
if you
not?
guys don't know, like there's no worries. Anyway, so pretty much a triangle here, right angle here. So say this is the arc. This is the initial angle the ball is fired at. Okay, right? Theta here. We know. So sine is the vertical component here, and cosine it'd be the horizontal. I don't know how to explain this. Like
So
anyway, this
basically,
is
like if
sine
you think,
theta.
yeah, that's all we
This
like. So correlate cosine theta with horizontal and sine theta with vertical, right? We don't want to go too deep in like what exactly they are, but like when you think of an angle, there's a horizontal component of that angle and vertical component, right? So if you want to go you want to go sine theta and cosine theta, right? You can go on now.
yeah. Sine and cosine aren't like variables, by the way. They're like operations. Like this,
Hmm.
if we gave theta like a numerical value, cosine theta would be another numerical value. It'd be like another degree.
That
Or actually, no, it
calculates,
wouldn't be
yeah.
degree. It'd be like just a value.
It would be
So pretty
degree.
much, if they give
Okay.
us theta here, which is the angle that the ball is fired at, and they give us the initial like velocity of the overall ball, say this is like x here. This is x sine theta, and this is the vertical and horizontal components are x cosine theta. This is an actual variable, by the way. The horizontal
Hmm.
would be x cosine theta, like the side to side, and the vertical would be x sine theta. So what can we do with this? Now we have
Could you define it? Did you define X?
okay, so x would be like the overall initial velocity. So say they
So
say
just
I'm
use
shooting,
V, no?
yeah, v naught. I guess I could call it v naught. V
So
naught. Yeah,
yeah,
you can go.
so when we're using acceleration, or sorry, velocity, you just use the velocity and then you have whatever Lucas did there, right? And yeah.
Okay, so we have okay, so say I have a cannon and I shoot a ball out at a 45-degree angle at 30 miles, 30 meters a second. Okay. I have 30 meters a second out, and to do any type of like math, like with kinematics to calculate any values I want, I need to have the vertical and horizontal components separately of the velocity because I can't do the math with them together. Like 30 meters per second doesn't plug into any of my equations. I need to split it into the x velocity, the x component of the velocity, which is horizontal. You guys know x and y axis. X is like this way and y is this way. I need to know x and y components of the velocity. And how I get these components is with this trig here. It's not super complicated, but like if you don't know trig, it's complicated. So I would take v naught here, and then this would technically be the horizontal component. Like if you imagine a triangle, this is a 90-degree angle here. This is the horizontal component of this line here. No, I mean vertical component of this line here. And this is the horizontal component of this line here. And basically what I did here is I got the values of these separate points here. And this allows me to plug in the kinematic equation because kinematic equations only take into like one dimension, either x or y. Like there's no kinematic equation that takes both x and y together to make something. This is an essential step. This would be like the first step you would do in any projectile motion equation. If you don't get it, it's okay. This is super complicated and it's too hard for day one stuff,
Hmm.
especially if
We
you don't know trig.
will, yeah. Yeah. This is like a lot of really hard stuff. Next class, we will go over the um main equations of kinematics that will help you understand projectile motion a lot better. So whoever like is whoever understood this, that's great. I know a lot of the people in this call did not understand it, and that's very normal. Like
Yeah.
I would not understand this like at the first class either. So next class we have some slides. We're gonna show you like all the main equations and how to get them, and then this will make a lot more sense then.
This
Does
is
not
like not
sound good?
representative for like how hard the class is. This is like
Mm-hmm.
very in-depth stuff. Like we're not focusing on this stuff. But also wanted to add, like when you do take physics, if you do in high school and stuff, a lot of the time you will have to split things into horizontal or like two components. You have to split things
Mm-hmm.
into horizontal and vertical. Okay. SOHCAHTOA. Oh yes, SOHCAHTOA is correct. So if I want to explain SOHCAHTOA to you guys, it pretty much means sine is equal to opposite over hypotenuse. Do you guys know the hypotenuse of a right triangle? It's the longest side. Opposite over hypotenuse. That's what sine is. So if I have a triangle here, a right triangle, three, four, this is a real right triangle, right? Is th 3, 4, 5 is a real right triangle, right? I'm pretty sure it's been a long time. I think so. Yeah, it is. Okay. So, so sine of theta is just a variable for an angle. But like we would always take sine of an angle. Sine, cosine, and tangent are all operations you do on an angle. So in this case, if we had 90 degrees, we all know a right triangle has a 90-degree angle in the corner here. And if we did sine of 90 degrees on this specific triangle, it would be the opposite side here, which would be 5 divided. Okay, wait, actually, you can't do it on 90 degrees. Wait 1 second. Say we did it on this angle here, right? We took sine of this angle right here. It would be the opposite side, which is 4 here, over the hypotenuse, which is 5. So sine here would just be equal to sine of whatever this angle is here is equal to 4/5. I'm pretty sure, right? That's how it works. Gotham, is that how it works?
Sorry, what?
Um, this is how SOHCAHTOA works, right? If I
Yeah,
if I took
yeah,
sine of this thing, yeah, Jane
yeah.
explained it
Hmm.
here. But sine of this angle here would just be 4/5 because it's the opposite over the hypotenuse here. And then SOHCAHTOA is just like a mnemonic, like a way to remember that sine is opposite over hypotenuse, which is OH. So cosine is adjacent over hypotenuse. So if I took cosine of this angle, it'd be 3 over the hypotenuse, which is 5. So that'd be 3/5 here. That's what the ka is. And toa is opposite over adjacent, which is tangent of this angle would be equal to the opposite, which is 4, over the adjacent, which is 3.
And then to like clarify what opposite, adjacent, and the hypotenuse are, if you take that angle theta, right? Like directly to the, can I annotate? Oh yeah, I
Oh,
can.
yeah.
Directly to the opposite side. I don't know if he already stated this, but this is completely opposite, right? So this is gonna be
This is in respect to
opposite,
this angle, by the way, to
mhm,
theta here.
for this angle, right? If we're taking this angle, the opposite of this angle is this side, right? It just depends on what side you're taking. And then when you do that, the hypotenuse will always be the this side, right? The length, or it'll be the longest, right?
Yeah.
So, and then whatever is next to that is just the adjacent one, right? A lot of this is very complicated. We don't want to scare you um doing this, but I think this is fun once you get to understand this.
Yeah. So that's pretty much it for this activity. Should we move on to the next stuff?
Yeah, yeah. Um,
Okay.
uh, just to clarify, we'll be like, next class, we'll be creating some equations using kinematics. It won't be anything like this. This was, we just got carried away in the
Yeah, this is
lab, but
unrelated.
next class we'll be creating some equations for the kinematics. Like what today we just covered like velocity, acceleration, displacement, and time, right? We started working with those variables. Next class, we will start like compiling all those into equations that we can solve for each of them, right? It's almost like 2x plus 1 equals y, right? So and x equals like 3, then solve for y. It's almost like that. It gets pretty fun once you understand a lot of it because you're just
If you guys
inputting
have,
stuff and then solving.
yeah, like it's just algebra at that point.
Hmm.
Um, Have you guys all taken algebra before? I just want to know like an idea of what math level we are. It's okay if you haven't. Yes, nice, nice. That's
And
okay.
if you guys haven't taken algebra, that's completely fine. We're more than happy to teach you guys algebra because it's very simple.
Yeah, it's not a big deal.
Hmm.
Okay, so I'm gonna move on from here.
Mm.
Do we want to go over this? Wait, this is like an AP level question. Like this is very difficult.
I
But
didn't
like
even read it. Wait,
I
particle
can
is
walk
not
through it if you guys want me to, but this would be like more
convection.
complicated than we can do. It'll take
T
me a bit to
equals
walk through it,
zero.
but I can try to explain it, or if not, we can just skip it because this is very difficult. If you guys want to do this or not, just give a yes or no in chat.
Oh,
It's
yeah.
okay. Yeah, this is very
We still take
difficult.
equations, right? Doesn't
Hmm.
Do you guys want to do this next time?
Too
Once we
confusing.
start creating the
You guys don't have to solve
equations.
it. I'll just be walking through it, see if you guys understand. Are you guys sure you don't want me to walk through it?
Too confusing. Too confusing. I think save this question for next time. Yeah,
Okay,
save
okay,
this
that's
question
fine.
for next class.
Okay, next time. Yeah, that sounds good. Okay, wrap up. We are on the wrap up section.
Yeah. So basically, do you guys so the previous questions that we did, right? The ones that we like solved for like the locate or the distance and like when we solved for the velocity, like when we multiplied the two numbers, was that a lot better for you guys? I just want to gauge like the previous two questions we had, the ones, yeah, you guys, yeah, okay. Those are probably gonna be a lot of what we'll do because that's like the right level, right? It's easy enough to where you guys understand it, but also we gotta teach stuff with it, right? So I've repeated this many times, but I'll just say it once more. Well, so today was just like an it was an introduction of the variables we will be working with, plus us getting carried away with a lot of the other stuff. But yeah, is it next slide? Wrap up.
Oh yeah,
Mm-hmm. So
this.
yeah, we learned about so the matter, atoms, and waves were just to get a feel of like what like how the world is made up, right? It's not like it's not gonna like I don't it's not gonna affect us in this area too much, but we just wanted to introduce you to that before we got into kinematics a bit. And then we solved a real life problem. We named the parts of an atom. We found some formulas. Yeah.
Someone asked a question about if you're supposed to write this all in a notebook. Not today. Today is like a large overview of the class. Like when we get to like equations tomorrow and stuff, what type of
Wednesday.
quarks are in a proton? Um, quarks are like separate. No.
Quarks are
Wait,
not,
wait, it's up and down, right? Up and down. It's
there's more flavors than up and down. There's also charm.
wait, up and down make up a proton, right? Though it's two,
Hmm. Two ups and one down.
yeah, two ups and one down make up a proton. That was the question. That's unrelated. That's like modern physics, I'm pretty sure. So yeah, okay.
So yeah.
Before I got distracted, I was we don't need to write like all this stuff down today, but like in the future in classes when we have like equations stuff, it's super helpful to write those down. And like in large concepts, like conceptual ideas, it can be helpful to write those down too. But physics is like kind of self-explanatory because like it's the study of stuff in the real world, like especially like mechanics and stuff. So you should if it makes sense to you, it'll like remember it like automatically to you. Oh,
Hmm.
you, it's okay. Shall I move on to the next
And
slide?
I don't know. Do we have an next slide?
Yeah. Oh, next
Okay.
time on Sunday.
Sunday, we were thinking of having class on Wednesday. Are you guys fine with that? Just to get, just so it's easier for you guys to, it'll be easier to remember it since it'll be, Sunday, Wednesday instead of Sunday to next Sunday where you guys have, where you guys could forget. So we'll have class Sunday, every Sunday and Wednesday. Um, don't get too scared of what we did at the end there. Just remember everything before that, right? What we did at the end was a lot more deeper, but what we did at the start is what you guys will be seeing more of. It'll get a little more complicated than that, but it won't ever get as complicated as we did at the end. And if it does, you'll have all the knowledge beforehand to do all that, right?
Yes.
So,
What time
yeah.
Wednesday? I think we're doing 2 to 3:30 at the same time, I
Yeah,
believe.
2 to 3:30 the same time. And yeah. And then do you want to ask the question about homework, Lucas?
Oh, would you guys like want homework for this class? If we had homework, it would be like to prepare you for like a final like quiz or like a Kahoot or something at the end of the course. So and like the winner would like get like a prize or something. We'd give like gift cards out or like something like that. Would you guys want homework for like a reward or something? Sure, you guys want
Hmm.
homework?
And if we did give him homework, it
It
would
won't
be
be like a
like
lot of homework. I don't
10
think
to
it would be a lot.
15 minutes max, probably. It'll
Yeah,
be
it
a
would
lot of
not
the
be a lot.
problems. It'll be a lot of the problems we did earlier, like the ones that, so it won't be hard, but I also don't want it to be boring. It's just to get the repetition in, because a lot of
Yes.
physics is like getting the concepts down. And the only way you can do that is by repeating, repeating, and repeating, right?
Okay.
So I think we're a bit early.
Are there any
It should
questions
be
about
from
anything?
2 to 3:30, but today was more of an intro day. So um do you have anything to add, Lucas?
No. If there are any questions, we can stay for the full
Yeah,
portion.
feel free to ask questions about anything.
Can you give starting problems for next week? What do you mean by that? I think our next class will be Wednesday. Like, I think we might be having classes every Wednesday and Sunday, which is different from what we originally said. But we're trying to. There's a lot of coursework we're gonna get through. Yeah, we do post homework on Google Classroom. Homework today. I think.
Oh. Do we
Uh,
have oh okay. I see why. Okay, we have the slides posted on uh Google Classroom, right? You guys got that? Mm-hmm.
yeah, there would be no homework until Wednesday.
Yeah.
If there are no other questions, there's no more content we're going over, so you guys are free to leave.
Mm-hmm. If you guys have feedback, feel free to like tell us if you guys